Hey folks, how's it going? This is Mr. Murray coming to you with a video on making quick exponential models, what you need to know. So in this video, I'm going to talk to you about how we use just a couple points to generate a simple exponential function that models those points. I'm calling this quick, and sometimes I might say simple, because in life, oftentimes the situations we're going to work with are going to be more complicated than a couple points. And maybe later in the year, we will talk about how to use our calculator to do regression with exponential functions, just like it did with linear functions earlier on in the year. But in this video, I'm going to present some problems for me, us, and you to do. And basically, we're going to be trying to use some given information to write a function that's an exponential function. So that is, it's in the form f of x equals a times b to the power of x. So our strategy is we're going to have a couple points at least. We're going to use 2 points that were given to find b, and we're going to use one of the points that were given to find a. And this is going to be just exactly like when we're working with geometric sequences. So when we had 8, 4, 2, 1, when we wrote the explicit rule by finding r and then calculating a by plugging in 1 for x, it's going to be the exact same idea, but just a little bit different because we might not have term 1 in the context of the points we're given, right? We might not be given x equals 1. We might be given another combination. Okay, so first, we're going to take a look at these kind of problems. Problems in which you may be given a graph and you might be asked to write an exponential function that goes with the graph. So first thing we might want to do is we might want to look at the numbers and ask ourselves a few questions. For example, what would we expect a to be? What would we expect b to be? Well, here, what I know is generally, when a is a positive number, the function is above the asymptote. And when a is a negative number, it's generally below the asymptote. So here, I'm going to expect my a to be positive. And also what I notice is that the numbers are getting closer to 0. So I'm going to expect my b to probably be a number between 0 and 1. That is probably to be a fraction. So by looking at the graph, you start to build some insight that's going to help you, because then when you come up with your answer, that will tell you whether your answer makes sense. So here what I'm going to do is I'm going to use the fact that 1, 8 and 2, 4 are on the graph. Because what I essentially need to do is I need to make this function a times b to the x. And the thing is, you need to figure out an a and a b. Okay, but what you know is that if I plug in 1 for x, f of x is 8. If you plug in 2 for x, f of x is 4. And then it would appear if you plug in 3 for x, it's 2. 4 for x, it's 1, and so on and so on. Okay, so what I'm going to do to find that ratio is I'm going to do this. I'm going to note that to get from 8 to 4, I need to multiply by b 1 time. Because to get from 1 to 2, I need to multiply by b 1 time. And then I'm going to need to multiply to get from 8 to 4. I'm going to need to multiply by a half. Okay, so if we look at this as x1, y1, and x2, y2, okay, what I'm doing is I'm looking essentially at the ratio here. I'm looking at the ratio y2, y1. Okay, I'm looking at that ratio. And then I'm setting it equal to b to the power of x2 minus x1. In other words, you could even say it's equal to b to the x2 over b to the x1. So it's like you have this proportion. Is this relationship proportional? Interesting. Okay, so what you're essentially trying to do is you're essentially trying to find the b value. And if you have two terms, one after another, the b gets you from the lower number term to the higher number term. So 1 is less than 2. So what I know so far is that I have f of x equals a times 1/2 to the x. And now I'm going to choose a point and plug it in. I'm going to try to choose a point with a smaller x value because that's generally easier when you're working with exponents. So I'm going to make the choice for 1/8. So I plug in 8 for f of x, and I plug in 1 for x. And sorry, that's an A. I know sometimes my A's look like Q's. But that is intended to be an A. Okay. So 1/2 to the power of 1 is 1/2. And then to get rid of the 1/2, I'd have to multiply by 2. So I get 16 equals A. And now that I know A and B, I write my final equation. F of x equals 16 times 1/2 to the power of x. This confirms what I believe, right? The fact that A is positive and the fact that B is between 0 and 1. So that's the process. You use your 2 points. Notice I'm choosing sequential points. 1 and then 2. So the x is exactly 1 more than the last one. And that allows us to use some of these ideas that we've talked about from sequences. All right, your turn. Go ahead and try this. So I want you to do this. I want you to find your 2 sequential points on the graph. I want you to use those points to generate a function in the form f of x equals a times b to the x. So go ahead, pause the video, get your formula, and then when you're ready, unpause, and you can see what I got. Okay, so hopefully you use the points 1/8 and 0/4. So you can see that as you go up by one term, what's going on? And actually, we have these reversed. So it's probably good to look at it the other way. So we're going from 0/4 to 1/8. So as we go up by a term, what's happening? The y's are doubling. So b, you multiply by b once, and you get 2. So b is equal to 2. Okay? And then, now that I know that, I'm going to plug in 0, because it's nice to raise numbers to the power of 0. So 4 is equal to a times 2 to the power of 0. And anything to the 0 is 1. So 4 is equal to a times 1, which is a. So our final answer is f of x equals 4 times 2 to the power of x. Okay, and you could check your work by plugging in 1. 2 to the first is 2 times 4 is 8. You could also try -1. 2 to the -1 is 1/2. 4 times 1/2 is 2. So it looks like it's checking out. Okay, so now I'm going to take a look at a problem where you're given points and you need to use the given points to figure out the function. Notice that as you can see here, the points are sequential. That is, again, -2 and -1. They're 1 away from each other. So I'm like going up by 1. So what you need to do is you need to ask yourself, what am I multiplying by 2/5 to get 2? One way to do it is to take 2 and divide it by 2/5, which would be 2 times 5/2, which would be 5. The other way is to think about it in your head. What times 2/5 is 2? Well, if you multiply 2/5 times 5, the 5's cancel and you get 2. So here, my b value is equal to 5 because as x goes up by 1, y is being multiplied by 5 because remember, you have the exponential where you're multiplying over and over. So you're going up once, multiplying by 5. So b to the 1 is equal to 5, which means b is equal to 5. And then what we're going to do is the same as before. So now, do we plug in -2 2/5 or -1 2? I would argue that we should plug in -1 2. And that's because I would rather have as little fractions as possible. If I plug in -2, I'm going to have a fraction here and a fraction for the y. Okay, so 2 is equal to a, and then remember what we do with the 5, it becomes 1/5. And then we're going to multiply by 5 and by 5, and we get 10 is equal to a. So our final function is f of x equals 10 times 5 to the x. Okay, if we check our work, we plug in -1, we get 1/5. 10 times a fifth is 2. We plug in -2, we get 1/25 because it's 1 over 5 squared. 10 over 25 is 2 over 5. All right, your turn. So now I'm going to give you 2 points. They're sequential points. And using those 2 points, what I want you to do is to create a function in the form f of x equals a times b to the x. Here, our points are 1, 8 and 2, 64. So go ahead, pause the video, solve it, and then when you're ready, unpause, and you can see what I got. Okay, so what you know is that as you go up by 1, x is being multiplied by 8. So it means that as you go up by 1 means r to the first, and times 8, 8, right? 8 times 8, 64. Okay, so now it tells me, in other words, b is equal to 8. So now we choose our point. I'm going to choose 1 and 8. So f of x equals a times 8 to the x. When x is equal to 1, y is equal to 8. And 8 to the 1 is 8. So a needs to be 1. So that 1 times 8 is 8. So in this case, we're just going to write f of x equals 8 to the x. Because here it says if a is 1, you just don't write the 1. Technically, if you were to write on a test or quiz f of x equals 1 times 8 to the x, I wouldn't mark you down because that's completely correct from a mathematical perspective. All right, now I'm going to spice it up a little bit. Similar idea, but we again need to figure out the formula here. So we have 2 points. Again, what you need to notice is that they're sequential. So 2 and 3, they're one right after another. So to get from here to here, right, so basically if I plug in, if I do f of 2 and I multiply by b, I get f of 3. Right? Now if I wanted to get to f of 4, right, I have to multiply by b again, because f of 4 is f of 3 times b. Whenever you multiply by b, you jump forward by 1 on the x-axis, essentially. So notice, if I take f of 3 and I multiply it by b, that's the same thing as taking this and multiplying it by b. So you get this. But look, what's b times b? So for every time you want to jump up by 1, you need to multiply by b. So if you want to jump up twice, you're multiplying by b squared. And we're going to see an example in a second of how we work that in there. But here, forget about this. let's just worry about b to the power of 1 because we're jumping up by 1. So what we're going to do is we're going to ask ourselves, what do I multiply by 2/3 to get to 5/9? And that's like taking 5/9 and dividing it by 2/3. And that's the same as taking 5/9 and multiplying it by 3/2. We can do a little canceling, 1 and 3, and we end up with 5/6 as our number. And let's verify this. 2/3 times 5/6. So 2 times 5 is 10, 6 times 3 is 18, and that's 5/9. Perfect. So B is 5/6. Now this is one where it's going to be very difficult to find the A value, so I'm going to plug in 2, because if I'm going to be squaring a fraction or cubing a fraction, I would prefer to be squaring it. Me personally. So what I'm going to do is I'm going to set y equal to 2/3. I don't yet know A. B is 5/6, and 2/3 is the output when you plug in 2. Okay? Now, the 2/3 is 2/3. When I square 5/6, I get 25/36. Now this is not easy to clear this out, but remember, to eliminate this 36, you need to multiply by 36. To eliminate this 25, you need to divide by 25. So what I'm looking for is 36 over 25. So what I get is 72 over 75 is equal to A, because 36 times 2 is 72, and 25 times 3 is 75. And now these can be divided by 3. This divided by 3 is 24. This divided by 3 is 25. So it's 24/25. And so our final function would be f of x equals 24/25 times 5/6 to the x. And what we would do is we would check this by plugging in 3. If we plug in 3, we get 125 over 216. And then we do 24 and 25. So this will turn into 1, and this will turn to 5. And then 216 is an interesting number. What's interesting about it is that when you divide it by 24, you get 9. So you get 5/9. So this works. So that's our final function. F of x equals 24/25 times 5/9 to the x. It's a complicated one. Yikes. So you have this function right here. You have that you need to find. You have the points -1, 8 and 0, 16. So what I want you to do is go ahead and pause the video, try to solve this one, and then when you're ready, unpause, and you can see what I got. Alrighty. So look, I've got a sequential term right here. I'm going from -1 to 0. So I'm going up by 1 term, b to the first. And from 8 to 16, I multiply by 2. So it tells me b to the first is b. B is equal to 2. So what I'm looking for is f of x is equal to a times 2 to the x. I'm going to choose 0. So when I plug in 0, what I need to get is 16, and 2 to the 0 is 1. So a is 16 because 1 times a is a. So f of x equals 16 times 2 to the x. A little bit more simple than the one above. All right, so if you need to, go ahead and review anything from this past few minutes, and then when you're ready, I am going to go ahead and move on to the next problem. All right, so this is actually the last set of problems, and what I'm going to be doing here is showing you what happens when you need to jump by more than one term. Right? So this idea of creating models has been somewhat oversimplified by the fact that you're always jumping up by one. So all you have to do is divide one thing by the next. But what's unfortunate is, well, what if I want to go up by two? So here's what we have to think about. I know that I have these three terms sitting right here. This is term 1, this is term 2, and this is thing 3. So f of 1, f of 2, f of 3. When I plug in 1, I get 300. When I plug in 3, I get 75. So what I don't know b, but I know that if I multiply f of 1 times b, and then times b again, I get f of 3. So what I know is that essentially f of 1 times b squared is equal to f of 3, because it's f of 1 times b times b. But f of 1 is 300, and f of 3 is 75. And by dividing, I get 75 over 300, which is 1/4. And by taking the square root, I know b has either got to be positive or negative a half, but it can't be negative a half because b has to be positive. That's like by definition of an exponential function. So b has got to be a half. Okay, another way to think about it is this. What do I have to multiply by 300 to get 75? 1/4. But I have to multiply a number twice, right? I have to multiply a number by itself twice. So b squared has to be 1/4, so b is equal to a half. So see here, we would jump up by one step, so it would be b to the first. Here we jumped up by one step, b to the first. So that's why I was writing it that way, because we were jumping up by one step, so that you would have a sense of notation for if we jumped up by two. Now I just go back and I plug in. So now I've got 300 equals a times 1/2 to the 1. So 300 equals a times a half. So 600 equals a. So our function is 600 times 1/2 to the x. All right, here's one for us to try. Let's take a look here. So first, notice it's not sequential. We're jumping up by how many terms? From -2 to 1, we're going up by 3. So we're going to go from 2 to -2 to -1, -1 to 0, 0 to 1. So what power of b are we going to associate with that? b to the third. Good job. Now, here it's going to be a little bit more complicated because I'm going to need to do 27 over 8. If I take 27 over 8 and I multiply this by 8, you can see I get 27. So this is literally a number that you multiply by 8 that gets you to 27. So how do you get rid of a cube? You use a cube root. So b is equal to, and what's the cube root of 27? Well, what times itself equals 27? That would be 3. And what times itself equals 8? That would be 2. So it tells us that b is going to be equal to 3/2. And so now we again plug in. So not y. Let's plug in 1 and 27. So 27 is equal to a times 3/2 to the power of 1. So 27 is equal to a times 3/2. So to cancel the 3/2, I times by 2/3. And that cleans up as this. So a is equal to 18. So my final function, bringing it together, 18 times 3 halves to the power of x, or 1.5. Okay, you could also use a calculator to help you with some of this evaluation. All right, last we try, or rather you try. So here I've given you a function. You've multiplied a number and you've gotten another number, and you can see the number of terms you've jumped up by. So using this information, go ahead, pause the video, find the function, and then when you're ready, unpause, and you can see what I got. All right, so here I'm going up by 3 terms, 4, 5, 6. So we associate that with b to the third, jumping by 3. And then what do you multiply by 4 to get 32? You multiply 8. So you can imagine again, 3, 4, 5, 6. You have 4, 32. So you had to jump up 1, 2, 3 times. So multiplying, and if you multiply by the same number, that's what the cubing means. So what times itself is 8. That will tell you b was equal to 2. We kind of just talked about that. So f of x equals a times 2 to the x. So let's plug in 3 because I'd rather do to the power of 3 than the power of 6. So 4 equals a times 2 to the 3. 2 to the 3 is 8. So 4 equals a times 8. Divided by 8. And a equals 4 to the 8. 4 over 8 rather, which is 1/2. So f of x equals 1/2 times 2 to the x. Let's check that with 6. So you do 2 to the 6, 2, 4, 8, 16, 32, 64. Half of 64 is 32. So the idea behind this is, look, you're given a couple points, and you're given now what we know about this idea of exponential growth. And now that we've talked about geometric sequences and exponential growth and exponential, how those things change over time, we're now going to use as a couple points to write a function. And this is very similar to what we did with arithmetic sequences when you had to jump way down the line, except now instead of using slope, we're using square roots, sometimes not even that. All right, so folks, best of luck. Make sure you take a look at the activities for today. Keep the questions coming. Don't forget to love math. All right, and remember, you can do it. All right, take care. Have a wonderful day.